In this video we will cover 5 problems that review target 4D. We're going to start with question number 16, move to number 17, 18, 19, and number 20. So let's go back to number 16, and it's a vertical motion type of problem where we need to use this formula right here and plug in the initial velocity and initial height to get our function. So I need to fill out this formula right here. I'm going to write it a little bit bigger, and the only thing that we really need to plug in is something for my velocity right there, and then also something for my c, which is the constant, and that is represented by like your starting height, your initial height. So if we look through the problem, we see that our upward velocity, which would be our initial velocity, is indeed 9 feet per second. So that's going to go right here. And then we also have a starting height of 13 feet because that's the height of our fountain. So I'm just going to rewrite my function here, but I'm going to plug in all my information. And by the way, this negative 16 here, that stays the same all the time unless something with gravity changes. But that's going to be a standard number. We're going to change v. That ends up being a 9 because that was our initial velocity. We have t, and the t never changes either because t represents time. So I'll talk about that in a second. Let me just finish writing this. So this is going to be our function. Now back to what t is. If you ever wanted to replace t, that just means you'd replace it with a number of seconds, and that would give you the height at that second, or well, at that point in time. So if you plugged in a 3 for t, that would give you the height at 3 seconds. That's all. So question number 17 now. We're going to need to draw a rectangle here, so I'm going to go ahead and do that. It's talking about side A and side B, so I'm going to label side A and B. It says side A is unknown, but we know that side B is going to be 9 inches less than side A. So B will equal, we'll have side A, but we want 9 inches less than that. So we're going to take away 9 inches from side A. That's going to give us our side B. And we need to create a quadratic equation that calculates the area. So area is modeled by this formula here, length times width. And we'll say that our length would be B, and our B is going to be A minus 9. And then our width was up here, that's going to be A. So length times width is A minus 9 times A, and that's going to be our area. That would be our quadratic equation that calculates the area. We don't have to distribute anything. This would work. Question number 18 is another vertical motion problem, and I need to fill in my values for V and C here. So I'm going to rewrite my equation a little bit bigger first. In that negative 16 that was in the beginning of my equation here changes to a negative 5 just because of some things that were mentioned in the problem. So we'll just go with that, treat it as a given. And our velocity to start was 19, so I'm going to go ahead and circle that in our problem here. That gets substituted in for that v, and then we also had a starting height of 5 meters, and that's going to be plugged into that c. So this is how it should work, or I'm sorry, this is how it should look when it's all filled in. Question number 19 involves a gardener that wants to put fencing around an area which is 30 meters squared, and part A is asking us to find an expression that represents length. So we're already given width, that's down here, that's W, we just call it W, so I guess actually we're not really given it, but we're going to use that to write our expression for length. And in our problem it says the length is 1 meter longer than the width, so our length is going to be our width but plus 1. And that will be 1 meter longer. And that's all we had to do. B, though, is asking us for an equation, so we have to use the area formula. So that's going to be length times width. And we need to just start plugging in values. So we know that the area was going to be, or it is 30, and that's going to be meters squared. Our length is represented by W plus 1, and then our width is just W. So we need to solve this equation now. And a quick way to solve any type of equation is just to set it equal to 0 and then graph it, and you could find the x-intercept, which would represent the solution. So first thing I want to do is set it equal to 0, so I subtract 30 from both sides, and then I'm left with 0, which equals my W plus 1 times W, and then minus 30. Now this is when we graph it, and remember, we're going to treat 0 here as y. So this is what I actually end up graphing. Here's the graph that I did in Desmos, and you could see that you can't see the entire parabola, but what you can see are the x-intercepts. You have x equals a -6, so that's going to be the point of this intersection of the x-axis, and then down here, well, I guess I should say to the right, we have 5, 0, and that's another x-intercept. So which one do we want to use here? Well, W, or in this case our x values, represent the width. So it would be impossible to have a width of -6 meters, so we're not going to use this one. We will use, though, 5, and that will be a width of 5 meters. In our last part here, C, it says that we need to determine the length of the rectangle, and we already had our formula for length up top. Length is going to be W plus 1, so all we have to do is plug in our width, which was 5, and then we're going to add 1. So we have 6 meters as our length. Now on to question number 20, and this is actually, I think, one of the more challenging problems of this set of 5. We have a frame here, and this is going to be the framed area in orange, and then we have some windows, right? This is going to be the first window, another window, and another window right here, and we need to figure out the value of x. That's what it's asking for. So I'm going to use my formula for area, and we're going to say we want to find the total area of this entire I guess frame, so including the frame and the windows, and we're given that was 316 inches squared. Now, which would be the trickier part, it's finding an expression that represents length as well as an expression that represents width. So our length is going to be from here all the way to this side. So what does this actually represent? Well, we know that the frame here, so this is the orange part, that's a uniform width. It says it in our problem. So we know that that's going to be 4 inches. That's this distance. So then from this point here, that's going to be 4. Okay? Throw a 4 down there. And that happens over here too. So from this point to about right there, this is going to be 4 as well. Now each of these windows is going to be x. So you have x on this side, x there, and then x there. So from here to here, this is going to be, that'll be x. And then we have that situation from here to here again. So that's going to be another x. And then from here to here, that's going to be another x. So this entire length here is going to be 4 plus an x plus an x plus a third x plus 4 again. That's going to be our length. Now we want to find our width, so that's going to be this entire side here. And again, back to the width of our frame, we know from this point to about like here. I know it's kind of hard to see, but that's going to be 4. And then that happens from here to here. So that's going to be 4 as well. And now we only have one of these x values, the blue one. So from about here to there, that's going to be x. So for our width, we have 4 plus x plus 4. Now let's go ahead and rewrite this. It's going to be 316, which equals, we have 4 plus 4, that's going to be 8, and then we have 3 x's, so that's going to be plus 3x. And then on this right side here we have 4 plus 4, that's going to be another 8, plus just 1x. And that simplifies my equation a little bit better. And like that last problem, we're going to graph it to solve. So I'm going to take away 316 from both sides, because we want to set it equal to 0 so that we could graph it. Remember, our new equation is going to be y equals this expression, which is 8 plus 3x times 8 plus x. And let's go ahead and graph it. Actually, there should be a minus 316 in both of these, so don't want to forget this. So here comes the graph now. Again, this was done on Desmos, and I'm not showing you the entire parabola just because all we're looking for are the x-intercepts, and we know there's 2, so as long as you see both of them, you know you're good to go. This x-intercept is going to be negative 16, and we cannot have an x value. Remember, we were looking for the side length of our window. That is negative, so we're not going to use that one. We're actually going to use this one here. That's going to be x equals 5.27. So that is what our x value is going to be, 5.27. And that's going to be in inches. So let's go ahead and recap the 5 problems that we did. The first one was a vertical motion problem where you're setting up a function. Our second one, we were creating a quadratic equation, and that involved our area formula. Question number 18 was another vertical motion problem. And then 19 was a problem that involved the fencing, and we had to figure out what the length was and then what the width was. And then lastly, question number 20 was dealing with the windows and the frames and everything. So that x value was 5.27 inches. And remember, you could also solve this equation through other means using algebra, but I think it's a little bit easier to use the a graphing calculator if you have one available.